Hi, my name's Saab Zembi. I'm going to be covering tonight's session on exploring protocols and services on internet-connected embedded devices. Got underneath that the context of CCTVs as embedded devices on an IP network. I've got an apology to make, first of all, just to start with, because the original talk I was going to give, I can't give that at the moment. It's going to be a lot less technical than I originally intended. And if people were looking for something technical and they would like to leave, I won't be offended. It's just that I'm a freelance researcher, and a lot of the work that I've been doing, I've had to sign an NDA and give somebody first refusal of the work that I've been doing. So if you have, if you were looking for a really, really in-depth technical discussion today, that's not what we're going to get. What I am going to cover is this topic, but I'm going to give you some insights that I wish I had when I started to look at embedded devices, and I'll try and cover them because those are the sort of things that you can't get from reading in books and looking on the internet and doing those sorts of searches. So it's going to be a lot less technical than originally intended, so be warned now. Security rules for the masses. Now, these are some of the rules that are basic rules that I found, which are not the security rules that we know and live by ourselves, I know. Security products are secure. Now, in CCTV, in embedded devices, you're going to come across lots and lots and lots of different applications. And all these products are sold as security devices, and we all know that they're not secure at all. Existing technologies are secure. Well, we know that as well. If you look at all the different internet protocols that are around, they're not very secure. If you look at all the services around, they're not very secure. We've had them for years and years and years. They haven't changed at all, and they've not been improved for security. What we have seen are adaptations to actually set up some sort of security. Passwords equal security. We know that's not true. Any hacker who's worth anything knows how to crack passwords or have the tools on how to use it. IP address filtering equals security. That's not true either. We know we can all basically spoof IP addresses. Firewall equals security. That's not true. Professional security services equal technical security. Now, part of the reason I wrote these down here is because these are some of the assumptions that a lot of people work on in the CCTV world. And you know, it's amazing that when I first started looking at CCTVs, I was shocked that people in the security industry were actually working on these as if they were real life and you could live by them. Private investigations, that's the name of the conference this year. CCTV, voice over IP, video conferencing over IP, TV over IP, all these involve the use of embedded devices to a greater extent. And you know, what you're going to find in each one of these types of devices will account for a greater percentage of the total bandwidth, more than all the previous devices put together. I know at the moment CCTV, even though there's compression products at both ends, one to compress, one to decompress, you still find that the bandwidth of these organizations is far greater than the total bandwidth of those organizations of all their internet usage that they had previously. Each of these uses or will use existing protocols and services regardless of their maturity for security. And that's massive potential for private investigations. If you're interested in surveillance, you can use CCTVs and actually follow people around on CCTVs. A session for those German speakers that were around this afternoon, you may have gone next door to hacking CCTVs. If you did, you'd know what I'm talking about. If you didn't, because you were put off the fact that it was in German language, I attended that session. It was run by German speakers, it was in German language, but the slides were in English, and it was a very good session, and I've got a slide, I amended my presentation to take account of that. There's a hell of a lot you can do. And there's a potential, obviously, with all these sorts of services for storage companies to come along and take advantage of that, and all this is going to create a headache for security, privacy, and data protection. If anyone's involved in those fields, you'll have an idea what I mean. Today's aim, what I'm looking to do is, I'm looking to create an interest in yourselves in the future of embedded devices by understanding the context of the present and the past practices. So what I want you to do is basically understand what I'm going to cover today, and hopefully, if you do, take that into consideration when you're exploring embedded devices and what you can do with them and what you can pick up for the future. I'm going to try and offer some pointers on exploring technical insecurities by looking at CCTVs in a non-technical approach. You can learn from the technical stuff quite easily. You can, it's fairly straightforward. The non-technical knowledge that I've gained so far in the last few years, that's not as easy. So what I'm going to try and cover are some of the insights that I've had. Background, basically I've spoken at police and local authority manager conferences on benchmarking the security of network CCTV systems. In January next month, I'll be speaking at IPSEC, which is the International IP Security Conference, and I'm covering two sessions. One is again on benchmarking security of CCTV systems, and the other one is on how to specify secure CCTV systems. I've been involved in auditing work of CCTV systems. Previously I have installed CCTV systems as well. I've got a database that I've put together on CCTV cameras based on a spider that I've written. I've looked at the vulnerabilities of the critical national infrastructure's use of network CCTV systems. And partly that involved me going out, looking at the critical national infrastructure, and taking devices with me, one device for finding wireless CCTV, a computer that I use connected to the internet, plus a recording device and recording what I'd seen. So basically, I spent a lot of time on the road recording a whole range of findings of how parts of the critical national infrastructure use CCTVs. And there's a story from a colleague of mine who used to be a policeman, and he used to do a lot of surveillance work. And it's not a surprise, we got talking obviously about what he found when he was using his wireless equipment when he was doing surveillance work. And he said there was one time he was observing a building across the road, and right next to it was a bank. And using the equipment he had, he was able to see 5 cameras in a bank next door to the building he was in, and he could see all the way down to the vault, absolutely everything, and it was unsecured, it was open. Yeah. Now, that's the sort of thing I was talking about in the slide that I had earlier on about security for the masses. People come along and they put this equipment on thinking it's going to be useful and it's going to be secure and nobody's going to be able to access it. They haven't really thought about it in great detail. Next, research database for embedded devices. Again, most of the work that I've mentioned here, that's the sort of thing I would have included a lot more of in today's sessions and made it more technical. What I'm going to cover instead is use of embedded devices, communicating embedded devices, examples of CCTV as a communicating embedded device. Exploring embedded devices can be fun. Seriously, it can be, and if you start to look at it, you'd find out that, you know, that's where a lot of the future is going to be. Also, hopefully identifying some vulnerable protocols, not in great detail, just by mentioning them, finding them, and hopefully get you interested enough to explore them for yourselves in great detail. A basis for discussion on the importance of securing and communicating embedded devices in your organization, the same as any other device. While the context is more important than the technology, you can't get context from the manuals or websites. So that's what I hope to be covering. What I'm not going to cover, as I've said already, is how to hack embedded device. I'm not going to tell you how to find CCTV cameras or web cameras or exploiting the vulnerabilities. If I started to do that, a lot of the work that I do at the moment, I won't be able to do because I'll be blacklisted by the police authorities that I work for. I'm not going to provide technical workings on anything that I'm going to cover today. I'm not going to cover risk assessment for CCTV systems or any individual embedded device. I'm not going to cover how to select communicating devices or the standards involved in communication, encryption, compression, graphics, and images. Right, content, embedded devices, why embedded device interesting, IP-based CCTV systems in the context, components of CCTV systems, and there are a lot of components, you'd be amazed. The fun part of it, protocols, and the are the vulnerabilities in internet-connected devices any different from any other devices, network devices in the context? And lastly, the future and the context of that. Examples of some of the devices that we have around that are embedded devices. They're all around you. Most of you know, you see them around. There are absolutely hundreds and hundreds and thousands that you have around the home. Uses are all around us. Consumer products, everything from TV, whether it's digital or analog, set-top boxes, DVDs, DVD players, VCRs, cable boxes, MP3 players, and any other mobile players, PDAs, kitchen appliances, fridges, toasters, microwaves, toys, games, telephones, mobiles, decks, video cameras, global positioning systems. Manufacturing's been a big user for a long time. Automobiles, they've been using for robotics, control systems, ignition systems, engine control, braking systems. There's 1,001 uses there. Military, for putting together the control systems they use in aeroplanes, missiles, weapons, office automation, including fax machines, digitizers, posters, medical I forgot. That includes cardiac machines, prosthetic devices, pumps, infusions, monitors, scanners, smart card readers, door entry systems, and lastly, as you know, networking and network monitoring, modems, routers, access ports, bridges, all sorts of things. So, you know, there are devices around us. In this room alone, we've probably each got at least one device that we're carrying on us, if not more, within our bags. Yep, there are in use all around us. Why would anyone want to look at embedded devices? I believe that embedded devices are going to be taking center stage. They're going to take the center stage in the coming internet-connected revolution. Now, we already know that our mobile phones and most mobile phones are beginning to start connecting to the internet, and you can get email, you can get web access, and so on. And so many devices are going to move that way. There's been much talk about fridges connecting to the internet. I know there are some, but that's not widespread. You know, so that's going to happen in the next few years, and all of these are going to have, as I said, internet connection. The independence of embedded devices. That's quite important because most of the devices that you might use in the office in terms of PCs, they are controlled by you. You turn them on, you turn them off, you check the security, everything's sorted out, you know what's what to some extent. A lot of these devices, they are completely independent in the sense that once you switch it on, you've configured it however you think it should be configured. Once you've done that, you're going to leave it. It's going to be independent. You're not going to do much else with it. And that's one of the reasons why embedded devices are important. There's beginning to be far more reliance on embedded devices. You know, look at the internet, for example. It relies on, you know, products that have embedded devices, switches, routers, all that stuff. They rely on embedded devices, and that's the internet. Now, many of those products are coming into the home and controlling a lot of what we do in the home. And they either will or do control what you can and cannot do. They will they will soon be used to form mini networks managed by other devices designed specifically to manage that type of network. And I'll cover that in a bit more detail as I go along. Is the embedded device security mature enough for all this future role? I mean, that's a very important question. And hopefully, by the end of it, you'll get an idea of that. And what makes embedded devices interesting? So, you know, why look at them? What makes them particularly interesting? They usually fulfill a very specific function. That's quite interesting. So they're supposed to do one thing and one thing alone quite often. However, as time's going on, they're not necessarily doing one thing and one thing only. They're usually assumed to be as secure as necessary. If they are physically secured, they are often unattended. Many are remotely controlled out of the box. Many have lots of cool, undocumented or unconsidered features. And that is a very important one. The supercomputers of yesteryear will be the embedded devices of today. You know, what about the supercomputers of today? Now, I've got a mobile phone, which, if anyone's got one of these XDAs, it can do a hell of a lot. It's far more powerful and can do far more than, the first lot of computers that I had in my life. And for many of you, that's the same. Your mobile device is far more powerful than anything you had a couple of years back. The technology you have in your pocket or your bag today is probably far greater than the technology that almost any leader in the world had about 10 to 15 years ago. And that's quite important. That's major. And that is happening. And as we go along, we're going to find that the products that we have in our homes are going to be amazingly powerful. Advantages of using embedded devices, often they've got a very specific purpose. Yep. And they have very specific functionality, can reliably be left to work independently without, so it should be any intervention, once configured appropriately, can be left once powered on. Are there any downsides? Let's take a look at what can be done by using CCTVs as an example. That will give you an idea of the downsides. Lack of knowledge in configuring them without additional technical assistance, that is a major downside. Again, you'll get an idea of that once I explain the way CCTVs work. If it has to be controlled remotely, it's open to network insecurities, that's a fact. Connecting a device to a network means using existing internet services and protocols. That is a definite downside. A flying tour of how we got there. Basically, need for simple devices. I'm going to fly through some of this. I want to get to the latter stuff. Need for simple devices. The chips have got better and better. Operating systems have basically expanded, and you've got far more operating systems for embedded devices today than you've ever had in the past. And they've been growing and growing and growing. Consumer devices, our lust for consumer devices, companies making modems, companies like Cisco, 3Com and so on, they've basically helped, to get to where we are. Mobile phones, PDAs, militaries, manufacturing, the trends leading to the future, as I said, chip technology, RAM chip technology, communicating devices, killer applications. All phone companies are looking for killer applications, and they have been for a long time. The G3 companies are still looking today. I've got friends who work in venture capitalist companies, and they still haven't found killer applications. They are still looking, and they are envisaging these to be on embedded devices. Greater uses. The prices have come down considerably, and it just makes the whole thing far cheaper, and lastly, consumer demand. How much more of what we already have? How many mobile phones can we have? In England, where I live, I don't know about you guys, but if it's true in Germany or wherever else you come from, if you're on a contract, after a year, you can change your mobile phone. And every year, we've got people who are expanding, changing their mobile phones. MP3 players, again, every 6 to 9 months, we're getting a lot of people who are changing their MP3 players because they're getting better and better. Network devices, how many more of those can we have? Wireless network access hardware, robotic hardware. There's a hell of a lot that we've already got, and we're getting far more and more of all that. What will be connected to the internet in the future? Yep. The question that really should be, what won't be connected? We're going to get absolutely anything and everything connected. That's why wireless is going to be so important in terms of security. How these were and are connected. Usually it's open wireless. I've given the example of a surveillance system in a bank. That was open wireless. You can get open wide, closed network, depends on the use and proximity. And again, I'm going to cover that in more detail. So in terms of CCTV systems, I'm not going to cover, as I said earlier on, searching for live CCTV cameras or webcams in any great detail. They are covered very well by other sites. If you are interested, I've got 3 down there. I'll give you a moment if you want to copy that. They are fairly good, and there's a lot. If anyone is interested, I have a lot more information that I've found far more than that's on those sites. I can't reveal it now, but if anyone wants to contact me individually, I've got my email address at the end, and I can pass some information on to whoever. There was also a session earlier today. The earlier session was very interesting, as I said, even though it was in German, English slides. You did miss out. When the slides come out, I'd really recommend you look at the slides because they are very good, very useful. One of the personal privacy techniques that they mentioned was to use a laser pointer. Another one was a laser hack. Basically, the idea was if you use a laser pointer at a camera, it burns and it ruins the camera, and that way the camera can't record what it's trying to see. So that was I have come across that, but I've totally forgotten that. But it is a very, very important point. That is illegal. If you ever done it in England, I don't know what the law's like here, but if you ever done it in England, you would be done pretty bad. And with 16 million cameras in England, you're not going to get that far. Webcams, CCTVs, what's the difference? Well, often when I say to people I do research in CCTVs, they say, oh yeah, webcams, you can get them on the internet. Well, there's a couple of major differences. One is in terms of image quality and what they were made to do. Webcams are there to put on top of your computer to connect directly or indirectly into the network. Whereas, you know, the CCTV is going to be there. It's meant for surveillance. Far better image quality is what they were intended for. And, you know, as I've said, you know, availability of hardware and software to expand functionality. The two things have completely different range of software and hardware. It's not necessarily the same. The remote control functionalities are different. I do know that there are various hacking tools and which enable you to control remotely somebody else's webcam and so on. So if you're interested in that sort of thing, it is out there. You can do that, but that's not what is supposed to happen with them. Therefore, requirement of the other functionalities. What makes 16 million cameras for 60 million people so important? The answer is their security. And what we mean by that is the security of the cameras, not the people. Now, why on earth would we have 16 million cameras in the UK? We have cameras, watching cameras. We have cameras around the UK in underground. If you go to the underground, you can go to any of the central London underground stations, and you could probably find at least 50 to 60 cameras if you know what to look and where to look. Some of them are open, some of them not so open. Yep. In the motorways, all motorway exits have cameras. So they know when you come on, they know when you go off. Traffic lights, there's cameras. When you go to pedestrian crossings, there's cameras. If you drive into London in your car, there's a congestion charge, and the cameras there will record your number plate. So the technology's there to pick out your number plate and charge your car or the registration holder of your car for the congestion charge for driving into London. There are 16 million cameras, and that is phenomenal for, as I said, 16 million people. And do we feel any secure? Did they stop the London bombers? Okay, CCTVs in the UK. As I said, 16 million cameras, 60 million people. It's still increasing. There are more and more cameras. In the last 15 years, the British government has spent a lot of money getting cameras in, and they're in housing sites where they've thought to have vandalism problems. They're absolutely anywhere and everywhere, but most of these schemes are actually run by either the police or local authorities. And because some of these cameras are quite old, they are in their replacement cycle. And because they're in their replacement cycle, what they're doing now is they're not opting for the closed systems, they're opting for IP-based systems. CCTV stands for, in case you'd forgotten, closed circuit television. When you put an IP camera on the internet, it's no longer closed. It's daft, isn't it? Yeah? They still call it CCTV, but you see, these cameras that they're putting in are no longer closed-circuit television. They are those type of cameras that are made to put on to the internet. The UK is still often cited as the worldwide example of successful use and implementation. I know this, a lot of the people I know who are in the police forces, they've been involved in other countries. And this is quite important. Much of what I'm covering here on this slide are things that I learned the hard way, and I wish I'd known some of this when I started researching CCTV cameras, because it would have made a difference to the approach I took in looking at CCTVs. So police from the UK actually go right across the world advising other governments on how to implement systems. So if you've had, in whichever town or city or country you come from, if you've had people come over advising yourselves from England the chances are they were advising not on the technologies, but they were advising on how to manage the surveillance and use of the information. Yeah? That is very important because the police do not have any idea at all of any technologies that they're using. What they're very good at is how to use the technology. It's a bit like me, being very good at using our video recorder to record the programs we have on the days that we want them, but we don't know how it works. We don't know how to install it, and we don't know anything else about it. Yeah? It's a very important point there. So it has been cited as a worldwide example. Success of identifying and following movements of the London bombers, that's known. They did manage to, the bombers that were successful in carrying out the bombs, they did watch them on the videos, and they did find out that a few weeks before that, there came down reconnaissance visit, what times, and all that took place. Unfortunately, it's after the event. What the British government, the British police often advises on how to use these systems to find suspicious behaviour, identify suspicious behaviour, and all those range of things. UK has a lot of expertise. Perspectives, do think about it. And I know I've put it a couple of times in this slide. UK population of 60 million, all these cameras. Network CCTV research. As I said, some of the work I've done, database compiling using spiders, benchmarking of security systems, vulnerabilities of network CCTV systems and critical national infrastructure, vulnerability matrix for devices on embedded systems. Again, I will emphasize, although I'm not covering the technicalities in this session, if anyone is interested in information, it will be available at some time, and it will be available free because the people I've signed this NDA with basically looking for sponsorship to have it under their name, so it will be available, and it will be available free, but if anyone is interested and they want to talk about it, you can get in touch with me. First of all, forget the technology. It all starts with physical security, stupid. Now that's very important because quite often, where you haven't got cameras watching other cameras, they've gone the other extreme. They've gone and put cameras in positions where anyone can come along and reach and just knock it with something, and that's the security gone. Now, they are no longer recording what they want. And I'd say to anyone, when you're looking at, if you're trying to identify and you're looking at a building and you're doing some security work about the physical security of the building, do check that out. That is very, very important. There's no point in going to the control room and looking at the control cameras and everything like that. You need to get out there and look at the cameras. Are the cameras themselves secure from being tampered with? Because again, other stuff that I've come across is it's easy to come along and snip wires, because although the camera's high enough, the wires start from right at ground level and they go up to the camera. It doesn't take much to come along and snip the wires. So there's a whole range of things. So the first thing is, are the cameras physical secure? Yeah. And IP-based CCTV systems, they're completely closed. Simplest is a home network, part of an internal network, standalone internet camera. Closed system, as I said earlier on, when they first came out, closed circuits television were actually closed. They required camera and viewing station to be very, very close to each other due to the cabling, and if they weren't that close, they had to use optical cables. That's just the technology that was around then. This is what I've seen in the UK. Couldn't take advantage of digital technology very easily, so the midway was a complete digital IP system. I'll cover that again in a bit more detail. Okay, so let's explore IP systems. Network setup, there's internet setup, protocols and services we can observe, and the complication of standards. As I said earlier, I'm not going to cover the details of the standards. The fact that there are so many standards, there's no single standard for a lot of things that go on. What's the basic CCTV system need to be able to do? Very basically, when they first came out, all they really did was convert image from a format, into a format which can be transmitted to a monitoring device. Record that image for future viewing, to be controlled remotely, and use and work with existing communications technology. A CCTV management system, again, taking a big system into account, basically all that needed to do was enable management of a large number of cameras remotely, control recording, access to recording, and viewing of data. Network CCTV components. Cameras, I imagine when I first started to look at them, all there was just a camera, just like the video cameras that we have. And there's far more to each of these devices. Each camera, because it's got an embedded device, it does run a full-fledged operating system. They've got applications. They've got a variety of chips. There's things in there for image manipulation. There's software in the camera quite often. There are chips that may deal with that in terms of the conversion from into an image back to another format. There could be compression, there could be decompression. You know, it depends entirely on the type of camera and what you want it to do. So the whole range of things that will be in that camera. Management software, either near to the unit or at the other end. Viewing software, again, could be at any end, it could be anywhere at all on the internet. Recording hardware, recording software, and there's lots of ways to implement this. We're going to look at some examples of that in a short while. What about security components? That's very interesting. Security components in a CCTV system are actually secondary to the system's functionality. What you find is that, again, I mean, when I started to look at CCTV systems, I was very surprised by the fact that they are so insecure. And I assumed that they would be secure and that security would be one of the things that would top on the list. But it's not. They are functionality-led, and they always have been, and they always have been by the vendors. Yep. And it's like almost any other consumer devices that are out there. They are entirely functionality-led, and that was really amazing. I was very surprised that they are such. Let's look at a successful vendor's offering. Now, I'm going to choose a vendor that I think is a successful vendor. It's a vendor that's known. It's the vendor that the guys next door, when they covered the talk this afternoon, they looked at, and it's a company that it's been around a long time. It's Axis.com. They are possibly the market leaders. I'm not picking on them for any particular reason. That they are more vulnerable than anyone else. I'm not looking at their products for any other reason other than the fact that they are fairly well known. Either they're typical of functionality or they lead in the functionality quite often. They provide plenty of information on the site, and that's really good. It's good and it's bad because what they try and do, they provide almost as much information as some of the open source systems around. And I say almost as much. There's a lot more they could provide, but they provide tons and tons of information that if someone wanted to learn how they work, it doesn't take much. Yep. And that's part of the reason that I'm not going into technicalities, and I don't feel bad about going into the technicalities of these systems. What I'm going to do is I'm going to go onto their website, and I'm going to show you some of the things on the website that they've got, which are really, really cool. So if you really want to mess around with CCTV systems and the protocols and take advantage of them, I'm going to show you some of the things that are out there, some of the cool things that are out there. Let's take an approach a hacker might take looking at this information with the aim of identifying what is worth exploring for exploit purposes. The website does provide sales product data, very, very important because they're trying to sell on functionality, and if you know the functionality, that gives you pointers as to what possibly you might want to look at in detail. Product technical data, they provide manuals, how-to documents, they provide examples, and very importantly, they provide firmware and firmware upgrades. Last year, if any of you came, you may well have been here and heard a speaker speak about upgrading or downloading firmware and playing about with it on your own system. It was a very, very good talk, and if you attended that talk or you like playing with firmware, you've got firmware available on the website. What are the recommended setups? I'll cover those, as I said, on the website and with the information they provide. What's likely reality in terms of what they cover? You see, I've covered part of what happened in the UK. For most systems that were installed in 1992 to 98, government funding was available. Government funding isn't available now in the same way that it was. And again, some of these are not technical, but if you're serious about looking into them, you need to understand what the market was like, how it changed, and how it's changing for the future, because it depends entirely on what camera or what CCTV scheme you actually want to look at, because if you don't know what you're looking at, you will be collecting the wrong information like I was, because I was trying to collect information of the CCTV systems of that time when I first started. And really, that was almost a complete waste of time because most CCTV systems in the UK were actually a lot older than the ones I was looking at. I was researching the current systems of the day, but not all the companies and all the schemes around England had those systems as they were then. So, you know, in terms of wherever you're looking, whether you're looking for working with a company and you're looking at a scheme on their part and how secure it is, you need to go back to when it was installed, what is it, how old it is, and how it came about and so on. There's a whole range of things that, you know, you really should look at as to how it came about, which, again, as I said, I wasn't aware of. So you can break it down to a couple of periods. And in the last 5 years, technology has changed a lot of that. Whereas way, way before that, the systems were completely closed virtually, very little being open. Between 98 and 2000, that's when you started to get things with middleware in, where you got products that you could connect to from closed systems. You can now put middleware in that made it connect to the internet. And that was around about that period. And that did carry on for over past 2000, but most of the newer systems that came about after 2000 to now have been changed. And there's a couple of changes I'll mention on the website as we go on in terms of some of the services and some of the things that they're offering. For those being installed now, again, they are very, very different than the ones that we got last year. Some of the services, I mean, an example I can give you is on the Axis site, most products, and I do mean most products, a year ago were running TFTP. Now, if anyone knows about TFTP, you'll know how insecure that is. Yeah? Now, the newer products are running FTP. Yeah, big change. Yeah. Okay, so you see, you know, there's a lot you need to understand. And that's why I say, you know, taking things in context is actually very important, because looking at the manuals and so on, there's stuff that you're going to get. You can get that in your own time. If you need pointers, again, I keep saying you can email me and I'll help you. But it's very, very different for virtually anything and everything out there. And there are lots and lots of camera companies using lots and lots of different components. There are only a few suppliers of these original components, but what the camera companies have done is they've taken a whole range of these components, put them together in a slightly different way, and they've got something else slightly different than someone else. Yep. Whatever is not on the website can be searched for in Google Archives. Yep, Google is useful for that sort of thing. Older technology management, analog to digital multiplexers. Most schemes run by police, local authorities. I've covered that. Installed by CCTV specialists. No networking experience. Many mixed systems are in use today, not built for security, but for functionality. Again, emphasize that. This is an example of the remote network system setup. You see there wonderful, on the left-hand side, network camera, PC, switch, broadband router, broadband modem, internet, remote computer. Now, does that really happen? Well, sort of. It doesn't happen completely. This is the way they like you to imagine it. This is what's on their product literature. But if you look at most of the schemes today, they've not got necessarily a switch at that point there. They may have both of those. They may only have one of those that acts as they may have a broadband router modem instead. They may have one thing rather than the two. Camera technologies. This is very important. The control, the pan, tilt, zoom. These cameras can move around, look at whatever they want to, and you can remote control these things, and that's fantastic. You can view them remotely, you can get remote audio. Not all cameras come with audio, only the special ones do. Part of the reasoning is, if you look at some of the cameras around in the UK, for example, at motorways, obviously they're not going to record sound. They don't need to record sound. Whereas if you look at some of the ones that might be in the town centres where the trouble spots are, they may well be recording audio. One of the problems you may find is that when you start recording audio, the data protection implications are very different than if they're just recording your picture. Just to bear in mind. Yeah. Remote upgrades for software, day and night use, that's very important. Compression, intruder sensors, image conversion, email notifications. All these things are not the things that were in the first few cameras that came around, but that's what you're going to find on all the websites now. For all the cameras that are available, these are the sorts of options. DVR viewing systems, local, remote recording, CD tape, you can decide where you want to record it. You can record it anywhere, and it's fairly simple and straightforward. If you viewing somebody else's system, you can then record what you're viewing on someone else's system elsewhere. Very simple to do, not that hard. They're programmed, could be manual, automated, event-based is very important, and image-based. So you can have a whole range of things that you can set based on the event or the type of image. So, for example, again, as I mentioned in London, the car systems in London, for the congestion charging, they will record the registration number of the car. Camera setup, let me just go here. Is it going to go? Yes, it is slowly. Right, let's look at some of the stuff we've got here. Again, this is the picture of what we had earlier on. I've got lots of tabs open here in Firefox. I'm going to try and go through these fairly quickly. You're going to see things, and hopefully some of these things on here are going to be picked up by yourselves very easily. Some of the stuff here. In setting up a camera system, assign an IP address for your camera, port forwarding. That's very useful. Some of you who know what you could do with that, that's very powerful. You can do a whole range of things with that, yeah? And this tells you on the website how you can do it, how you can use it. Very nice, very friendly. Designing a system, how you design a system. Now, the great thing about how you design a system is it gives you an understanding how, if you know when the system was designed, what it was designed for. Very, very useful information about why and how a certain scheme was set up in the way it does. Another good one, software. You can download the software to download the software, all you need to do is register, and in terms of registering, it's very simple, very straightforward. You don't need to provide much information. You can use as little information as you like, and I use my own information. I always do. Whenever I go onto a website, if I'm trying to get information from them, my belief is that I should give them something, and I give them correct details. Now, I know not everyone does give correct details, but the point is you can give as little or as much information as possible, and you're still going to have access to these things here. The Access IP utility. Fantastic tool, the Axis Camera Management. Again, a really good tool that you can control the camera. Axis Camera Station. I mean, all these things here, I think I've got a couple of slides which tells you more about them. Let's go through all these. Camera Explorer. This is really good. It's a cool tool. You can download onto, if you've got Pocket PC. I know the device I've just shown you, my XDA, my PDA, the reason I bought it was to be able to download things like this, because this is fantastic. I can go to a client site and I could use this software and I could tap into a lot of their cameras, and it's brilliant. And you've got it here, and you can use it, and they've got demos, so why not download it, make use of it if you've got the right device. Brilliant. This is the release text for that software for the PDA. This is really good. The pan tilt zoom support has been added for the following products. So it's these few products. All other Axis network cameras and video servers with PTZ were already supported in previous versions. So that is really good, because it means that you can tap into all the older legacy cameras. Really good stuff. The camera recording support, again, as I said, you don't have to try and find what the right software is. The software's there. You can just download it and use it. Again, a lot of this is supposed to be demo software, but I'm sure in a room full of people who know how to get things, you could work your way around that and use it for more than just a month demo period. Camera client station, yeah. There's useful stuff there. Let's try and work through fairly quickly. The management station. Now, most of you I'm not going to go into great details about this, but most of you may not be familiar with what some of this stuff is. What you find is where you've got lots of CCTV cameras, either for the police or for local authorities, you're going to have a room full of full of screens, and you're probably not going to have more than about 20 screens maximum for a single person to look at. On average, it's going to be about 10 to 12. And each person is going to be looking. So when they're looking, they're going to have be responsible for each of these 10 screens are probably going to be tapping into about maybe 30 cameras odd. So they've not got the camera on all the time for any specific camera. So what they're doing is they are shifting and they are moving around and working on a set of rules. And that's what this management software does. It enables you to view remotely on a fairly big system. And again, this is a fairly good product. This is really good. If any of you have come across one of the speakers that's speaking tomorrow, Dan, God, I've forgotten his surname. He's written lots of papers on DNS. He's very good. He's speaking tomorrow. But this DNS service, you'll know what you can do with it. If you ever read any of his papers, it's amazing that the way, the functionality, and it is functionality driven. If you've got a camera, originally the camera systems, when they first came out, the IP cameras, they only work if you've got a static IP address. Then they realized that not everyone has. So what did they do? They came out with a functionality that enabled you to make use of the cameras even if you haven't. And this is a dynamic DNS service. It's absolutely brilliant. What I suggest you do, if you're serious about looking at CCTV cameras, check this out because there's lots of fun you could have with this. Network video developer pages. This is really good as well because I can't believe that they provide so much stuff. That's why I said some of this stuff is a bit like, open source stuff in giving you things that you can do. Three lots of things that they've got here. HTTP API specification. Check it out, it's really good. The Windows development stuff, and then embedded scripting and general information. The embedded scripting stuff covers things like this. So this is the technical notes on the embedded scripting stuff. They've got, for example, technical note, pre- and post-alarm buffer in the Axis 2100. It's actually very good. If you take a look at this, this article explains the memory usage of the image buffer. If anyone likes buffer overflows, that's really good. This one here, the information is, live video at a high hit rate site. Again, if you go through this, so a lot of this stuff, the way they've written it, it's actually provided to make sure you as a user are getting the best use out of it. Unfortunately, this is great stuff for somebody who really wants to damage someone. It's amazing that it's out there and you can play around with this. This one here, enable telnet support on the Axis camera servers. I couldn't believe it when I came across this. I thought, are they really giving everyone whatever they want on this website? I'm running out of time, so I'm going to try and sort of move through because I want to get some conclusions about some of the stuff. So all the technical stuff, I assure you, you can get to this. It's not a big deal. You can find all of it on the website. It's easy to find. You could probably understand the technicalities far more and far quicker than I did. And we'd probably have fewer arguments talking about the technical stuff if I'd covered the technical stuff. But you get an idea, hopefully, and looking at the website, we haven't spent much time, only a handful of screens, and these screens give you tons of information. Hold on, that's that one, isn't it? Okay, right, we've done all these, and I've done them fairly quickly. What are some protocols? The obvious ones, web server services. Obviously, if you're viewing remotely, you have to run HTTP. And that's great, because the web servers that most of these embedded devices run, there's only a handful of embedded device web servers. So if you wanted to find out about what they're using, most of them use BOA. BOA on the Axis product did have a couple of problems about a year ago and about 2 years ago. On the Axis products, it doesn't have, and it has got a lot better. But if you want to find out and you want to explore, there's only a handful of web servers that are for embedded devices. FTP, TFTP, I've already mentioned, SMTP, SNMP. if you go on any of the vulnerability sites to look at SMTP, SNMP, you find there's tons of information on some of the vulnerabilities. I'm not going to cover them. I'm just trying to identify the fact that even though there's tons of vulnerabilities, these things appear in these products, and they haven't done anything to change anything. IP, TCP, UDP, you know, one of the things that the guys next door said earlier on, and those that were there would remember this, you know, this technology, it streams, it pushes, yeah? It works on UDP. That's quite important. For those of you who know how to play around with UDP, you'll know what you can do with that. Dynamic DNS service, so this is the starters. Other things, it got HTTPS, DNS, Telnet, shell scripting, PHP scripting. I think you may have missed that because I went through fast. Sorry, I missed it. I went through too fast. On one of the screens, there was PHP scripting. Task scheduler. What are the wonderful things you can do with task scheduler and PHP scripting? It's all there, and it's there for developers. Right, where are we up to now? Technical. On the technical side, remote cameras are not necessarily on the local network, so are not monitored as such. No intrusion detection system of any sort, no intrusion prevention, no log files. FTP is recent, it's definitely recent, but it's still, there are many devices out there still using TFTP. No evidence of login attempts, little or no encryption. The HTTPS is a recent addition. Security, IP, the security, I forgot to check, there's a page there which says, and it's an advert and the sales pitch and on the functionality. It's got their security, and under security it says IP address filtering, passwords, and multi-level passwords. And that's the total security on all their products. Innovations in scripting, fantastic. We're up to on the non-technical stuff. These products were not ever specified by technical staff. So they were specified entirely, absolutely, categorically by non-technical staff who didn't know what they were ordering. They were sold to them on functionality. Vendors don't understand security. Vendors aim to build on functionality and for interoperability. Remember Windows 95? Now, I went to a security conference with Microsoft many years ago, and one of the excuses or reasons, however you like to look at it, for Windows being so easy to hack was that when it was put together, one of the underlying principles was it had to be able to connect to anything and everything. And that was partly its downfall. Now, what you're finding is a lot of embedded devices, these CCTVs included, are built in that same way. They're built for functionality and interoperability. So because of that, there's so much that you can do with them that you wouldn't have thought you could have done with them. They're owned by police and local authorities, installed by non-technical staff, used by non-technical staff, maintained by non-technical staff, no IT security personnel involved at any point at all ever. Great, good fun. Right, a fistful of vulnerabilities. Where does one start? I'm not going to cover them, and I haven't covered them. I've hopefully opened up enough there for you to think about. If you do intend to explore it, always stay legal. There's a quote from Chris Simpson. Chris Simpson, sorry, I forgot his S in his name. He's the head of the computer crime unit in London. I do government work, and I do work with and have contact with the police and the high-tech crime unit. His quote to me when I asked him about wireless networks and being able to access wireless networks passively, his quote to me was, even if you are looking at things passively, the fact that you're not supposed to be there, as far as I'm concerned, is enough. So if you're in England and you are looking at things passively, be aware. That's the interpretation that he gave me, because I was leading on to what I could and could not do, and he quite categorically made it clear that there's no point in my questioning him any further on any of this. Okay, so then understand, the key thing I want to get to you is understand the background of each of the schemes that you're looking at. If you're looking at cameras, understand what the bigger picture, where it came from, who it belongs to, all that stuff. In England, you know, there are schemes and they have to publish their scheme data as part of data protection. Well, you know the rest. Then you need to test. Stay legal, that's very important again. CCTV is different from other network devices, and often outside of the network, they may be internally listed on an external DNS server. The use of web servers leads to indexing by Google because the fact that, as I said, they use HTTP and the web server that they use, all that stuff does mean that they can be searched and they can be found, they can be indexed, which is why the project that I was working on that I mentioned about spiders, you can send a spider to search the web server and you will get something back. It may be of value, it may not be value. Scripting tools, you know, that's how CCTV is different. That they do have scripting tools. Wide range of software available to achieve the same end. There are tons and tons of software. All you need to do is know what you're looking for, and you will find masses of free software to be able to explore CCTV devices. The implication of these for clients and other clients on the network and today, future CCTV networks, some units will have their own databases of rules for intelligence. Now, that's the way that things are going to go. Now, the work that I do, I'm trying to push some of these things that I've mentioned here. Direct connection to larger databases of images of unwanted people. Now, that's not what I'm trying to push. But the thing is, whether we like it or not, that's one of the things that will probably happen in the longer run. If it's not already happening now, creation of event-based intelligence, connections with other biometric technologies, connections with ID schemes. I'm a member of what's known as the Parliamentary IT Committee, and we have speakers from key industries speaking to Parliament about IT, and there was a session on ID cards and biometrics. And my suggestion was that we're going to get, sometime in the future, CCTV cameras that are going to pick out your ID cards, which are possibly going to have RFID, and they're going to read your RFID, and they're going to be attached to a database, and they will know whether the picture that's on the ID you're supposed to have and you there are actually correct, and whether you should be questioned by the police or not. And when I asked that question, I was told that is not the research that they're doing. Believe it if you like. Replacing passport control. Maybe not yet, but the thing is, it's going to happen at some time. We're going to have not just Big Brother, but far, far, far bigger brother. For sure it's going to happen in the interest of public safety, of course. What else? Future devices must be able to deal with not just spiders, worms, and bots of today. There are talks of deparameterization, but also intelligently. To deal with intrusion, to be used as remote hacking devices, deal with denial of service attacks, because it is quite possible fairly easily. Laser pointers, as we covered earlier on, breakdown of one component of the system. These systems, a single camera has got so many different components that if you mess one up, if you mess up the compression chip somehow, that's the whole system gone. If you mess up the encryption chip, hey, that's made it open. There's lots of different components, and it's fairly easy. If you start looking at something, there's something that can give. In the same way hackers have been looking at PCs, if you know what you're looking for, you can achieve quite a lot with these systems. And these devices are going to be able to cope with these things. Intelligent group coordinated defense at the middleware level. What you're going to get is systems which are controlled by a single intelligent middleware unit, which will control the way that the rest of the network and the connected cameras are working. What about non-CCTV devices? What protocols and services they're using? I'm going to go through fairly quickly because I know time is up and somebody might want to ask a question. Future approaches to connecting embedded devices. What can you do? If you're interested, start with the basics, use a risk approach. What are you not going to get caught doing wrong? Learn about new technologies, work with vendors if possible to create better solutions, stay legal, have fun. I'm sure going into prison isn't fun. Other interests of research work I've been doing or I'm looking at right now is the embedded device operating systems, security of remote control wireless devices, and a whole range of other stuff. This is how to get in touch with me. Suspicion breeds confidence. If anyone's seen the film Brazil by Terry Gilliam, you'll know what that means. Does suspicion breed confidence? Any questions?